Snowflake connector for Kafka. We'll go over the complete technical reference, the V4 architecture that Snowflake recently released on Kafka Connect. And let us talk about more on real-time streaming, Snowpipe architecture, and the throughput that currently Snowpipe streaming is supporting, and exactly once delivery. What is under the hood that Kafka is using in Snowflake? So we'll talk more on the overview and architecture. What is the Snowflake connector for Kafka? The Snowflake connector for Kafka is a sync connector. What is a sync connector? Let us say Kafka typically acts like a pub-sub model, which means you have publishers and you have consumers. Let us say you have different consumers or different producers are producing the data in topics, like you produce the data into Kafka using Kafka topics. But now I want to consume the data. Let us say if I want to read the data and write it into Snowflake, and you need some process in between. That is where the Snowflake connector for Kafka arrives. And we call it as a sync connector. A sync connector is the one that reads from one or more Kafka topics and writes directly into Snowflake tables. Each Kafka record becomes a row. The Kafka connector or the connector is a sync connector that reads data from Kafka topics and loads into Snowflake tables. It is built on Snowflake's high-performance Snowpipe streaming architecture. There is a classic architecture for Snowpipe streaming. There is a high-performance architecture. This Kafka that is there on V4, the version V4 that is recently released by Snowflake, is using Snowpipe streaming high-performance architectures. By design, it is a sync connector and it uses Snowpipe streaming under the hood, and it uses pipe as a centric design, which means it'll create the pipe, and it also uses a Rust-based core client for improved client-side performance, and that helps to lower the resource usage than the previous versions. And there are two kinds of distributions. One is the Confluent platform version. The other one is OSS Apache Kafka version. So choose based on what Kafka setup that you have. And exactly once delivery, which means guarantees exactly once, and order delivery semantics critical for financial and operational pipelines. So these are some key important architectural patterns that we have to understand when you use Kafka Connect or Snowflake connector for Kafka. The performance characteristics, why Kafka Connect is useful today. The maximum throughput per table it supports currently is 10 gigabytes per second, which is huge, enormous, I would say. And then the end-to-end ingestion latency is 5 to 10 seconds, which is, you can call it as near real time. And the pricing is by the gigabytes of data that it is produced or consumed. And the latest version that for the Kafka Connect for the Snowflake is V4. And different architectural benefits that you can see is its throughput and latency for near real-time analytics. It does also support the in-flight transformations via copy command syntax inside the pipe objects. And it does have server-side schema validation. All the invalid records at the server side goes to error tables for inspection. It'll also help you to does pre-clustering capability, which means the data is clustered during the ingestion when the clustering keys are defined on the table. And from a pricing standpoint, it is flat throughput-based pricing, which is exactly same as Snowpipe streaming high-performance architecture. Supported versions currently, the latest one that is released on the Kafka Connect from Snowflake is 4.x. Uh, it is recommended to upgrade if you are using 3 or 2 to latest version, and the 1.x is not supported. Let us describe more of what is Apache Kafka and what is the Kafka connector and differences, understanding the underlying framework. Kafka and Kafka Connect framework. What Kafka does, Kafka uses a publish subscribe model to stream records asynchronously. The publishers and subscribers need not be directly connected. The messages are sent to the topics and consumed when they're ready. So the way Kafka is set up is you have publishers that will publish the data into Kafka topics, right? And the consumers will consume the data from Kafka topics. What Kafka Connect here? It is a connect that is useful, that will help to read the data from Kafka topics and ingest into Snowflake table. That is Kafka Connect for Snowflake, which is a sync connector. So why Kafka, right? Typically, why people go with Kafka is because of its scalability, horizontal scaling by adding more worker nodes. It does support fault tolerance, which means it auto redistribution if a worker node fails, and offset management. It does track which records have been processed, prevents loss or duplication. The configuration management, it supports REST API for deploying and monitoring pipelines. Kafka is a very, very high performant architecture. It uses the Kafka brokers and distributes the data, can horizontally scale, helps you to provide the fault tolerance, and will have an offset management where you don't lose the data. And then it also supports REST APIs for deploying and monitoring pipelines. There are different connector types. One is a source connector, where you read the data from various sources and push the data into Kafka topics. The sync connectors that exports the data from Kafka topics to external systems. How the connector works. The connector is a wrapper on top of multiple objects underneath. Let us go each topic or each object that is involved to build that connector. So how the connector works with tables and pipes. Each Kafka record is treated as a row inserted into a Snowflake table. The connector can auto-create tables and uses the pipe objects as the entry point for all streaming data. So it does support default pipe mode, or you can also support your own pipe mode. So when you use Kafka connector, it will create a table in the target Snowflake database with a table name based on the topic that you would map in the configuration. And by default, it will create a pipe because it needs to read the data from the topics and write it into Snowflake. It does an intermediary object called pipe, and it helps you to map Kafka record keys to columns. And then it is also best for simple use cases where field names match column names. So default pipe mode is good when it can match your field name with the column names and auto creates a table based on the fields that are coming in a topic. And your topic is mapped to a table, and pipe is created with a table name -streaming. If you want to create your user defined pipe mode, you manually create a table and pipe, and you have an ability to create a copy into command syntax, and can also help you to do in-flight transformations like renaming columns, casting the data types, or filter some fields, or add some metadata. Typically used for custom transformations or complex schemas. And Kafka Connect does support schema evaluation on native tables. Tables with enabled schema evaluation equals to true that automatically evolve based on incoming records. Let's say if your metadata of the source has changed, like added a new column or dropped a new column, right? Added new metadata or changed the data type. The schema evaluation is supported for Kafka connector, and all the connector created tables default to enabled. Supported is adding new columns, dropping not null constraints on missing data fields. Schema evaluation is not supported for iceberg tables that are latest, while Kafka Connect also supports iceberg tables, but schema evaluation is not supported. Topic to table mapping strategies. There are multiple ways you can map topic to the tables. One is the static mapping. By default, the table name derived from topic name, which is uppercase, and if a topic name has an invalid characters such as underscores and hash suffix, so it does append underscore underscores, and it does support some hash suffix. If a pipe named table streaming used automatically, in static mapping, a default pipe with the name table name hyphen streaming is used. But if in the configuration, if you need to map an explicitly with some topics to some tables, there is an option. There is a comma separated topic that you can map to a pair of tables or a single table. It also supports regex patterns, like star underscore cat is a topic that is coming, or multiple topics coming with that. I want to map it to a cat table. Similarly, a star underscore dog, there are topics coming with wildcard characters. You can map it to dog underscore table, right? Similarly, map multiple topics to a single table, and also does support double quote names with special characters or colons. On the right side, you would see a configuration example. The first one is a direct mapping, where it maps your orders table topic to an orders table, customer topic to customer table. Let's say regex pattern matching, the second example, has the wildcard underscore cat or underscore dog with star in it, which is a regex expression that can map to a single table in Snowflake. And also, there are many topics to be mapped to one table with comma separated topic names. Like a topic 1 with a shared table in example 3, and topic 2 we are also mapping to shared table, but topic 3 is mapping to another table. The special characters, let's say a topic goes to 1 topic with a double quoted names, that topic colon 1 can be mapped to table comma 1. So that is how you can map to a special character topics to tables in the target. Your record underscore metadata is a Kafka record metadata in Snowflake. So you have a field called record metadata in Snowflake table, and there are different fields within that record metadata includes the topic name, the partition, offset, the create and append time, Snowflake connector push time, and then key, the Kafka message key, and the headers. So these are different fields that are part of the metadata, record metadata, and you can use this to basically validate different times, the create timestamp, and when is the message appended, and then when the Snowflake connector pushed the topic, right? And when it is ingested, and what is the offset at that particular position of that metadata, and what are the key value pairs attached to that headers, right? All of them can be tracked under the record metadata field, and typically it adds a 150 byte overhead per record, but you can also exclude that by setting snowflake.metadata.all property to false, so if it is not needed. Let us see setup and configuration, installing and configuring the connector. Setup task step by step. The connector requires pre-setup in both Snowflake and Kafka environment. And these are some high-level setup flows. The first one is create Snowflake objects. As we discussed earlier, create a dedicated role and the user, database, schema, and warehouse for this particular um, Kafka connector that ingests the data into Snowflake. Grant necessary privileges, including usage, create table, and create pipe, because it can auto create a table and auto create a pipe in a default mode. The second one is it uses key value pair authentication. The V4 supports only key pair authentication. OAuth is not supported at this time. And download the connector. You can download the Kafka connector from Confluent zip package or NOSS fat jar from Maven. So V4 not yet available as a native Confluent cloud connector. So you can use the custom plugin. So you would have to download a connector from Confluent zip package or NOSS fat jar. Install the Kafka Connect. This particular connect needs to be installed on all the Kafka Connect worker nodes, because you want that connector to be available on all the brokers and the worker nodes available. For OSS version, a bouncy castle cryptography libraries must be added separately if it is a OSS Kafka connector. Configure connector properties. And how do you configure the properties? Is create a connector configuration JSON properties file with Snowflake credentials, that key pair authentication we talked about, and topic mappings and connector specific settings. And finally, deploy and verify. Submit the configuration via Kafka Connect REST API, and that would deploy all of these configurations. Monitor the connector status and verify the data appears in Snowflake tables within 5 to 10 seconds. You would expect the latency of 5 to 10 seconds. The same thing that we discussed, and this is a configuration file in JSON format. You can see the different properties. The first one is the name, that gives the name of Snowflake Kafka connector. Connector class, it is important to give the right class name here. In this case, it is Snowflake Kafka connector, Snowflake sync connector. And in Snowflake URL name, provide the account URL that you want to connect to, the username that you have created, and then keep key value that is created, and the database name and the schema name, and the topics that you wanted to read from the Kafka worker nodes, and then topics to table mapping, those topics and what tables you want to map to, and also the key converter and the value converter. So it does string converter for key in this case. For the value converter, it just changes it into a JSON record, and then Snowflake metadata all set to true. So these are some properties that are mandatory when you are establishing connector configuration properties. How do you validate and do error handling? So there is server-side validation and there is client-side validation. Let us talk more on the validation and error handling. V4 supports two validation strategies that determine how bad records are handled during ingestion. How bad records are handled during ingestion. Choose based on your fault tolerance requirements. Server-side validation is the default mode, and client-side validation, you can also change that setting to Snowflake validation as client-side. As the default, server-side, what it does is it will validate the schema before the data gets ingested. And if there is any invalid records, it does capture into error tables for inspection. And the pipeline still continue to run, and all the broken records will be captured in error tables. Supports user-defined pipes, and error tables support replay of failed records. That is very important feature. Let us say if we want to enable the client-side validation, it does support connector validates records before sending to Snowflake. Fails immediately on invalid records. You can say errors tolerance equals to all. If you put, then it will send the data to Snowflake, and then it does the server-side validation. With errors dot tolerance equals to all, the bad records route to dead letter queue. Only default pipe mode supported. No user-defined pipes are supported at the client side. Better for strict validation upstream of Snowflake. So before you want to send the data into Snowflake, if you want to do all the validation at the client side, you can set up this configuration that will route the tolerance, the error records into dead letter queue. Otherwise, the server side, it will capture into an error table. There are certain limitations on the fault tolerance. Kafka topics retention limits is if offline longer than retention time, the expired records won't be loaded. Storage space limits. If Kafka storage is exceeded, some messages may not be delivered. Deleted Kafka messages are not reflected in Snowflake tables. So it is important to consider the retention time period of the Kafka topics, and also having enough storage space for storing when the messages are not delivered, so that you don't lose the data. How does the monitoring work for the connector? Monitoring and observability. Monitor connector health, throughput, and ingestion latency using Kafka Connect REST API. And Snowflake system functions are there, and then Snowflake connector push time metadata field is there. So there are certain fields that you can just continue to monitor to report it part of the observability. Kafka Connect REST API does connect, uses the get and to check the status of the connector, whether it is running, passed, or failed, and also check the tasks that are running, which are healthy or not. Ingestion latency, calculate end-to-end latency using Snowflake connector push time, connector buffer push versus current timestamp in Snowflake. Typically, you will see a 5 to 10 seconds latency. There are error tables that captures at the server side to capture the invalid records. Records include original payload, error region, and timestamp for replay. Snowflake system views, that is pipe usage history and streaming file migration history, to track costs and ingestion volume. Monitor via Snowsight's data load monitor. So you see those views are there in that you can capture the usage history for both pipe as well as file migration. Snowpipe streaming file migration. There are also JMS metrics. Kafka Connect exposes JMX metrics per connector, including records active, offset commit success percentage, sync record read rate, and put batch max time milliseconds. So these are typically important if you have your own observability in, that you can report these JMX metrics and can be seen in observability tools, and can also define the alerts and dashboards. Log analysis. You can set the log4j level to debug for connector troubleshooting. Key log patterns to monitor is pipe not found, offset commit, table created, schema evaluation, all of those. How do you migrate from V3 to V4? Now we have V4 in place. How do you migrate without losing your data? The recommended approach is V4 requires a new configuration, new connector class, removed properties. Some of the properties can be removed, change some of them to defaults. Migration from Snowpipe mode to Snowpipe streaming mode is supported without data gaps or duplicates. So what is important? The switchover must happen within offsets retention minutes. For example, let's say default is 7 days, but if you are not switching from V3 to V4 within that duration, you lose the data that is there because your retention period is less than your migration period. Review breaking changes. First, V4 uses a different connector class name. Several configuration properties were removed. Some defaults changed. Review the full changelog before proceeding. The second, prepare a new configuration. create a new v4 connector configuration and map existing v3 topic table configurations to v4 format using topic to table map property, and remove all the unsupported properties in the new config. Stop v3 connector. Pause the v3 connector to stop consuming new records. Record the current offsets for each topic partition. These will be used to resume in v4. v4 deployment. Install v4 plugin jars into Kafka Connect worker nodes, and then submit the new v4 connector configuration via REST API, and then ensure same consumer group ID is used to inherit offsets. Verify data continuity. Monitor ingestion in Snowflake to confirm no records were missed. Verify row counts match expected volume. Check error tables for any validation failures post migration. Once all of that is done, clean up the v3 resources. Once the v4 setup is done and verified, and if you are able to see the matching records between source and target, and then all the old configurations can be cleaned up. What are the limitations and considerations? Connector limitations and important constraints. It doesn't support OAuth. It does support Iceberg, but there is no schema evaluation supported. So to support Iceberg, we must create the Iceberg table manually before running the connector. SMT limitations. Most single message transformations work with community converters, but regex router SMT is currently not supported in v4. No native Confluent Cloud. So v4 is not yet available as a native Confluent Cloud connector. On Confluent Cloud, it must be installed as a custom plugin. Contact the Snowflake support for Confluent package. Retention-based data loss. Records expired from Kafka due to retention time or storage limits will not be loaded into Snowflake. Design your pipeline to handle Kafka retention windows. Bouncy castle required for OSS package. OSS Kafka version, the fat jar, requires bouncy castle cryptography libraries downloaded and add them separately to the class path. Apache Iceberg integration using the connector with Iceberg tables. So with interoperability in place, and while everybody is adopting Iceberg tables, how Kafka Connector works with Iceberg tables. So there are prerequisites before establishing Kafka Connector with Iceberg. Usage privileges on the external volume. We need an external volume if you are using an Iceberg table, and provide usage permissions to the role that Kafka is using to ingest the data. Iceberg table must be created manually before running the connector, and the schema evaluation is currently not supported. So the way you create an Iceberg table for ingestion is first grant usage on external volume to the role, and then create or replace an Iceberg table with external volume as your external volume, but catalog is Snowflake. Provide the base location and the Iceberg version, which is 1, 2, 3. Different limitations are the considerations that before doing creating an Iceberg table. Consider that you would have to create a manual Iceberg table. Connector doesn't auto create your Iceberg table. Iceberg data types, like it uses use Iceberg native types like array, object, variant, are compatible Snowflake types. Case sensitive nested keys, field names inside nested structures are case sensitive. Schema evaluation is not supported for Iceberg. Snowflake connector for Kafka. We talked about the throughput. It currently supports 10 gigabytes per second throughput with a 5 to 10 seconds latency. And then exactly once delivery, there is no duplication of the data that you would see. It does support key pair authentication at this moment. and then schema evaluation for regular tables, but it doesn't support schema evaluation for iceberg tables. But for iceberg tables, you would have to create tables manually and provide users grants to the external volume, and then migrating from v3 to v4, you would find no data gaps. So there is a way you can pause the v3 connector and then download your v4 connector and update the properties and resume with the updated configurations. With that, we have covered Kafka Connect for Snowflake, and it is a sync connector. So you can call it also as a Snowflake connector for Kafka. Thank you.